In this lesson, we'll focus on writing conditional statements, using conditional statements, and writing biconditional statements. At the end, there will be some truth tables provided for you. A conditional statement is a logical statement that has two parts: the hypothesis, which we denote with the letter P, and a conclusion, which we'll denote with the letter Q. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. We say, if P then Q. The symbol is an arrow, which means if P then Q. We're looking at just a structure of statements. The negation of a statement is the opposite of the original statement. In symbolic form, it looks like a little top piece of a congruent symbol for negation. It's written before the letter. So not P would be written in a symbol with that symbol and then the P. Here's how to write each of the different types of statements in words versus using symbols. The converse of a conditional statement is switching the hypothesis and the conclusion. The inverse is negating both the hypothesis and conclusion, and the contrapositive is negating both the hypothesis and the conclusion after you write the converse. A conditional statement and its contrapositive are either both true or both false statements. Similarly, the converse and inverse of a conditional statement are either both true or both false. In general, when two statements are both true or false, they are called equivalent statements. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. A biconditional is a statement that contains the phrase if and only if. It's written in symbols what looks like a little line between the P and the Q. Again, P just stands for hypothesis and the Q is conclusion. Example. Identify the hypothesis with H and the conclusion with C, then write each conditional in if-then form. The hypothesis on this is the if part, even though it's written second. This is the hypothesis. The conclusion is the then form. And it's the second piece of it. So for this problem, we would say if x is greater than 3, then x is greater than 5. It's about learning the sentence structure, which we'll then take and put this into two-column proof format eventually. You don't have to have a geometry or an algebra statement to use a conditional statement. For example, all members of the soccer team have practice today. The hypothesis is a member of the soccer team. The conclusion is that they have practice today. Conditional statement: if a person is a member of a soccer team, then he or she has practice today. Again, here's another example. We're going to identify the hypothesis and conclusion and then write in if-then form. All 30-degree angles are acute angles. So 30-degree angles would be the hypothesis. Acute angles would be the conclusion. So again, we can state this as an example. If an angle is 30 degrees, then it is acute. You can rewrite it so it makes logical sense. It has to be in if-then form without changing the meaning of it. hypothesis, 2x plus 7 equals 1 because x equals negative 3. Hypothesis and conclusion. If 2x plus 7 equals 1, then x equals negative 3. Write the negation of each statement. To negate it means to say it is not. So we would say the car is not white. If it states it's not, to negate it, then would to say it is. It's just the opposite. It is not snowing. To negate that, we would have to say it is snowing. Because it's already saying it's not to begin with, and we want to negate not, which means it is. In our next example, we're given a statement as a hypothesis, P, and a statement as a conclusion, Q, and we want to follow and write each of the different statements using the words that are given and the symbols. So the first is the conditional statement. If you are in New York City, then you are in the U.S. I'm going to abbreviate New York City, NY, then you are in the U.S. The converse means we switch the hypothesis and conclusion. If you are in the U.S., then you are in New York. The inverse would say, if you are not in New York, then you are not in the U.S. And then our contrapositive, if you are not in the U.S., then you are not in New York. Our first statement we know is true. Our second statement, by switching the hypothesis and conclusion, just because you're in the U.S. doesn't mean you're in New York necessarily, so that's false. The inverse, if you're not in New York, you're not in the U.S. That is also false. And then if you're not in the U.S., then you are not in New York. That is true. Our next example, decide whether each statement about the diagram is true. Explain your answer and the definitions you have learned. So this is looking about true and false. Besides looking at the structure, we look at understanding the problem. So given our picture, the measure of angle AEB equals 90 degrees. That's true. AEB we can see has a box, therefore it's a right angle, means that it's 90 degrees. AB and D are collinear. A, B, and D, that would be false, are not all on the same line. AC and CA are opposite rays, that is also false. They have to have the same initial point. The first one has A as the initial point, and the second one has C as the initial point or end point. So that's why it's false. Our next example, we write the definition of complementary angles as a single biconditional statement. If two angles are complementary, then the sum is 90. We know that the converse is also true. If two angles are 90, then they are also complementary. So our biconditional statement would say two angles are complementary if and only if the sum is 90. That's a biconditional. Putting the conditional and its converse in one statement together, knowing that they're both true. And then the last thing I have here are some truth tables that you can take a look at for a conditional, converse, inverse, and contrapositive, which will help you decide whether statements are true or false.